capital budgeting or the investment decision. So this is a topic that borrows a lot from the time value of money, in which a business organization is going to commit a reasonable amount of money into a particular project, and that project will generate the future cash inflows to the same organization. So you invest a considerable amount of money in a project as a business organization, and then that project is going to pay back in the future, and therefore the organization stands to gain. So one of the main aspects about the capital budgeting is that you are investing now so that you can benefit in the future, and those benefits in the future, in most cases, they come as a stream. When you invest, maybe you have invested 1M or 1 million, and then the project in which you have invested your money is going to be paying back in the future. Maybe each and every year you will be getting like 250,000 for maybe 7 years. So we are going to have a stream of cash flows in the future, but the investment has been done now. The other element is that you are investing here, and then the benefits you expect to get in the future. Therefore, there is an element of risk. There is an element of risk. Risk because you are not sure whether what you are projecting to get is exactly what you are going to get back. So there is some element of uncertainty. The future is not certain, so there is a risk that you might lose your money. The other element about this project is that when you commit that amount of money, the investment is irreversible, meaning that you cannot backtrack. You cannot backtrack. So the moment you have invested your money, it is either you gain or you lose. You cannot reach a point whereby you can withdraw the investment. So it is going to be irreversible. It involves a huge amount of money. There is some element of risk. The projects are normally irreversible and all that. So any commitment of an amount into a particular project. When we talk about a project here, we are talking about quite a number of things. You can invest in a machine, you can invest in a motor vehicle, you can invest in starting a new branch, starting a new product. All those are investments an organization can undertake. So we expect that those projects in which we have actually invested our resources, they are going to give back some benefits to the same organization that has invested that amount of money. So the amount of money that you are going to invest into a project is what we call the initial cash outlay. Initial cash outlay, in most cases, will be presented by IO, initial cash outlay, what we refer as the IO. Then in the future, you are going to get what we call the cash inflows. And we are saying that these cash inflows, they are going to come as a stream. A stream meaning that the benefits are not going to come as a lump sum. It is not going to be one single amount. It is going to be a series of cash flows. Year one, you get a certain amount. Year two, you get a certain amount, like that, like that. So it is normally a stream. It is normally a stream of cash inflows. And now we have the element of uncertainty, and here we are going to have what we call the cost of capital. The cost of capital is going to be our discounting rate, which is going to be given as a percentage rate. Maybe it is 10%, 5%, 12%. The discounting rate or the cost of capital we must be given in this question. And as we move along, I'm going to show you how to do it. The main aspect about this particular area is how to evaluate a visible or a viable project. How will I know that if I invest in this project, I'm going to gain as an organization? So what we call the investment appraisal techniques. It is the most important part, though I hope now you can be able to access the resources on the LMS. I will confirm today if all the topics are visible to you, you can be able to access those resources. When you go there, you'll find that I have actually provided all the literature about the topic, the characteristics of capital budgeting projects or investment decisions, which I have actually highlighted. They are projects that involve a reasonable amount of money. There is some element of risk. The cash is going to be received in a stream. We have also talked about a case whereby the project is reversible and such kind of things. I've also provided about the different types of projects. We are going to have independent projects, those projects that stand alone, those projects that stand alone, and actually they are not related with each other. The projects which are not related to each other, we normally call them independent projects. Those projects whereby if the resources are enough and both of them are profitable, we can start both of them because they serve different purpose. They are known as independent projects. Then we also have the projects we call the mutually exclusive projects. These are the projects that actually compete with one another because they serve the same purpose. Like, for example, you have a problem with the transport. So you are wondering, should we buy a bus or should we buy a minibus? So if we have those two alternatives, bus and minibus, because they are going to serve the same purpose, those are known as the mutually exclusive projects. Those projects that compete with one another. And if one of them is actually chosen, it simply means that the other one will not be chosen, mutually exclusive projects. So we have them, those literatures are provided on the LMS. And then the most important is on understanding investment appraisal techniques. These investment appraisal techniques are classified into two. We have the first category, which is known as a non-discounting cash flow techniques. The non-discounting cash flows techniques. We have come from the topic of time value of money, and we have agreed that in terms of value, an amount of money will have different values depending on the time that money is going to be received. If I receive the money now, the value is higher than the same amount of money that I'm going to receive in a year's time. And the process of getting the present value, we call it discounting. So when we say that these techniques are known as non-discounting cash flow techniques, it simply means that these techniques, they don't discount. We don't get the present value of the amount. Remember also, I have said that this project that we have, we are going to consider here is as investment decision. The cash flow is going to come as a stream. We are going to be receiving money in a series. Therefore, the amount that I'm going to receive after 2 years is not the same amount that I could have received right now. So, under these techniques, they don't discount the cash flows. They take the cash flows as they are, and therefore they assume that amount of money received now or in the future, it is going to have the same value. If I have 1,000 today and 1,000 that I'm going to receive after 3 years, they consider them to be of the same value. So they don't discount so that they can determine the present value. So they ignore the element or the concept of time value of money. These techniques are two. Number one, we are going to have a technique by the name payback period. Number two, we are going to have accounting rates of return. We normally abbreviate it as ARR. Accounting rate of return and the payback period. Those two techniques, they assume that amount of money, regardless of the time it is going to take for them to be received, the value remains the same. They are known as the non-discounting techniques. They are known techniques. So I want us to start with them, the non-discounting techniques, so that we can be able to know how do we evaluate a project and determine its viability using these two, the payback period and the accounting rate of return. I want you to go to your document that we have been using. I have shared the document with you this morning. We start with the payback period, and we shall use question 11 to illustrate, talking about Kestar Limited intends to borrow 4 million to finance either project X or project Y. The following are the expected net cash inflows for each project. And you are required, Roman 1, to calculate the payback period for each project. Roman 2, you actually advise the management on the project to invest in based on the results that you get on Roman 1. So how do we go about that? So allow me first of all to introduce the payback period, the PBP. The payback period. It is the duration it will take. The payback period is the duration it will take for the organization to recover the cash invested, what we refer as the cash outlay. The duration it will take for the organization to recover the cash invested. So if I've invested my 1 million in a project, how long will it take for me to recover my 1 million back? That duration is what we refer as the payback period. The payback period. So how do we get it? Like in this question, question 11, the amount to be invested is 4 million, what we have been given here. And the project X will generate this cash flows. Because this is an undiscounting cash flow technique, we use these cash flows the way they are. We don't discount them. We assume that 1,500,000 that will be received after 1 year, it has the same value of 1,500,000 today. The 1 million to be received after year 2, it is the same as 1 million of today. The same case with the others. We don't discount the cash flows. We use them the way they are. We assume this amount will remain the same way they are and their value does not change with time. So it is very simple to do a payback period. We shall do for X and Y separately. So you can probably refer from your other gadget as I go to the board. So for project X, The cash inflow for year one is 1,500,000. 1 million for year two. 2,400,000. And 1,200,000. That is the cash inflows. So for you to be able to calculate the payback period, you get here the accumulated cash inflow. Get a column for accumulated cash inflow. How do you create that column? You start with the first cash inflow, 1,500,000. After 1 year, we have recovered 1,500,000. After another 1 year, we recover another 1 million. So year one, we have recovered 1.5. Year two, we have recovered 1 million. So cumulatively, this is 2,500,000. So it is this plus this, we get this. Then we take this plus this, we get 4,900,000. This plus this is going to be 6,100,000. So that is how you have your accumulated cash inflow. You get the first inflow, then you go accumulate this plus this, you get this. This plus this, you get this. This plus this, you get this. That is how you create your accumulated cash inflow. So for you now to compute the payback period, you now ask yourself, remember our IO, the amount to be invested here is 4 million. What is to be borrowed and invested is 4 million. So we are simply asking ourselves, if this project is going to generate this cash inflow, how long will it take for us to recover the 4 million? So we go to the accumulated. You don't take more than what you are going to invest. So cumulatively, it will take 2 full years. This is the payback period. Payback period, PBP. It is going to take 2 full years, year one and year two. Cumulatively, we have recovered 2.5 million. Plus, how much is remaining for us to hit the target? Remember, up to year two, we have only recovered 2.5. There is a balance of 1,500,000, which will be received in year three. We assume that the inflows are actually distributed evenly throughout the year. If this amount 2.4 that is going to be received in year three, we are not going to receive this amount 2.4 in 1 month in that year. So we assume that the 12th month in year three, this amount, it is going to be evenly distributed. Like for example, we are going to receive like 200,000 per month. 200,000 per month for 12 months. So the amount is distributed evenly throughout the entire year. So it will take 2 full years, but for those 2 years, we have already recovered 2.5. The balance, which is 1.5, will be recovered in year three. Year three, that is where we shall recover the balance 1.5. You take the balance not yet recovered, you divide by where it is going to be recovered. The amount or the inflow of the year, it will be recovered. It is going to be recovered in year three. And the inflow amount for year three, it is 2,400,000. So it will give you in terms of years. So if you want to convert this part into months, you multiply by 12. But if you want to give your answer in years, you simply divide. So the payback period for project X will be 1,500,000. We divide by 2,400,000. We will get 2 plus 0.625, which will be 2.625 years. That is the payback period. That is the payback period. That is the payback period. Alternatively, you can take 2 plus 1,500,000 divided by 2,400,000. Then here you multiply by 12. If you want to have your answer in months. So that is what we have. When we multiply by 12, we get it is going to be 2 years and 7.5 months. 2 years and 7.5 months. Or you can simply say 2.625 years. That is the payback period for project X. You do the same.
Excuse me, sir.
Yes.
I didn't understand where we got the 2.
2 is here. We are recovering 4 million. Eh? So year 1 and year 2, cumulatively we have recovered 2.5. That is this plus this is. So it is 2 years. Then the third year, remember, if you take 3 years, we have exceeded 4 million. Eh? We have exceeded 4 million. So you take the lower, and then the balance, which is 1.5 in this case, you divide by the cash inflow of the year where it is going to be recovered. So you count the full years first of all, but don't exceed the cash outflow. So we cannot take 3 years, because 3 years it has exceeded 4 million. So you count the first full years it will take, and then if the amount has not been realized or recovered, the balance now you divide by the cash inflow in the year that you are going to recover the balance. Merawan?
Yes, thank you.
Yes. Project Y. So we have here 1, 2, 3, 4. The cash inflow, then the accumulated. The same procedure, but now use the cash inflows for Y. The cash inflows for Y, we have 2 million for year 1, 1,100,000 for year 2, 9 million for year 3, 1,500,000 for year 4. Then you accumulate them. You start with the first inflow. First plus second is going to be 3,100,000. The first, you do 3.1, it is accumulated for year 1 and 2. Then you add for year 3, this will be 11,100,000. And then you have plus this one is going to be 12,600,000. Once you have it like that, you can be able to now get your payback period. So you count first of all the number of.
Excuse me, Malimo, could you please look at the year 3 accumulation? Is it 11 million or 12 million?
This plus this is bigger, or this is 12 plus this is 20. Okay, correct. Thank you. That is okay. That is in order. So first of all, you consider the number of full years. Remember, our target is still 4 million. The cash outlay is 4 million. The same amount that we want to consider whether to invest in X or Y. 4 million. Okay. We count how many years? Full years first. Year 1, we have recovered 2 million. Year 1 plus year 2, we have recovered 3.1 million. So we cannot go here to year 3 because we will have exceeded. So we shall take 2 full years, year 1 and year 2. So the payback period will be 2 full years. Then plus up to the end of the year 2, we have recovered 3.1. So The balance is 900,000. We have recovered 3.1 and our target is 4 million. 4 million minus what we have recovered is 900,000. That 900,000 will be recovered in year 3 and the cash inflow for year 3 is 9 million. So this one will be 2 plus 900,000 divided by 9 million. You will get 0.1. Plus 2, this one will give you 2.1 years. That is the payback period for project Y. So we have the 2 payback periods. For X, it is 2.625. For Y, it is 2.1 years. Under the payback period, we normally prefer a project with a shorter payback period. A project with a shorter payback period is considered viable than the project with a longer payback period. So in this project Y, after 2.1 years, we have recovered our 4 million back. But for project X, it will take 2.625 years to recover our 4 million back. So we would advise the management to consider project Y because it has a shorter payback period. Because it has a shorter payback period. That is the end of that question. That is the end of that question. So understand how you do payback period. That is the procedure. Very simple. This column, you introduce it. You will not be given. You introduce it. You accumulate the cash inflows, and then from there you can be able to count the number of full years. You take that number of full years, then you add the balance divided by where the amount is going to be recovered a year. When you are dividing, you divide by the cash inflow. Don't divide by the accumulated. Remember, it will take 2 years. The balance is 900,000. 900,000 will be recovered from which amount? It is going to be recovered from the inflow of year 3. Don't use the accumulated inflow of year 3. Use the individual cash inflow of year 3. Then you add with the full years, you get the payback period. You get the payback period. That's all about the payback period technique of evaluating investment projects. If there is no question, we can go to the accounting rate of return. The accounting rate of return. Just a minute. So accounting rate of return, or ARR, divided by the average accounting profits divided by the average investment. The average accounting profit. This one uses the accounting profits and not the cash inflows. So the average accounting profits given by the sum of profits divided by the number of years. Sum of profits divided by the number of years. Average investment is equals to the initial cash investment plus the scrap value divided by 2. The scrap value is the residue value or the salvage value of the project. So maybe it is a project that is going to last for 5 years. After 5 years, the remains of that project, maybe it was a machine, the remain of that particular machine can be disposed at a certain amount. That amount that we can get from disposing the remains of a project is what we call the scrap value. The initial investment is the cost you incur to actually start the project. The cost of the project, the value of the project after the economic life, then divided by 2. The sum of the profits divided by the number of years. Let me confirm whether we have a question with accounting rate of return. Sorry, we don't have from the document that we have. We can create one question here. So let us consider this example. A company is considering investing in a project that will cost shillings 250,000. What we refer as the initial investment cost. IO. The project will have a scrap value after being used for 5 years. Will have a scrap value of 10,000 after being used for 5 years. The accounting profits from the projects have year 1, 2, 3, 4, and 5. Those are the profits from that particular project. Now you are told, can you calculate ARR? Can you calculate the ARR? It is going to be very simple. First of all, get the average accounting profits. Or the average profits, which will be equal to 120,000 plus 90,000 plus 150,000 plus 85,000 plus 70,000. Then you divide by what? By divided by the years, which are 5 years. The number of years are 5. You get the average profit. So that is 120, 190, 150, 25, 70, 550, 1,000. You divide by 5. Divide by 5 years. You get 103. Then you get the average investment. Take the initial cost, which is 250,000, and the scrap value 10,000, you divide by 2. That is going to be 130,000. How will you get your ARR now? With the average profit and average investment, so your ARR, accounting rate of return, will be average profit 103,000 divided by the average investment 130,000. Then you put your answer in the percentage. Put your answer in the percentage. That is going to be 79%. That is your accounting rate of return. That is the accounting rate of return. So that is how we do it. It is very simple. You add the profits, you divide by the years. In this case, the profits, these profits were generated in 5 years. That's why we have divided by 5. Then we take the initial investment plus the scrap value, you divide by 2. You get the average investment. Then you divide the two answers. You multiply by 100%, you get your accounting rate of return. You get your accounting rate of return. So those are the two non-discounting cash flow techniques. The two non-discounting cash flow techniques, payback period and the accounting rate of return. They use the values the way they are. They use the values the way they are. Then now we go to the second category of techniques. The second category of techniques, discounting cash flow techniques. The discounting cash flow techniques. So these techniques are aware that there is a concept we call time value of money. If I start a project and those benefits or the benefits from the project will be coming in the future, I need to be aware that that amount of money that I'm going to be receiving in future, the money in terms of value is not the same as the value of the same amount of money I'm investing right now. Remember, the investment is done presently, right now, but the benefits are coming in the future. So you need to sit down and argue. This amount of money that I will be receiving in the future, if I was to get them right now, so that I can compare with the cost of investment right now, how much are they valuable? So we need to discount them. We need to determine their present values. So all the values or the amount that we shall be receiving from the project, we discount. We get their present values. And then we sum all the present values, we compare with the present initial cash outlay. I want to invest 4 million. So the benefits, if I was to get them presently, how much are they worth? So that you can be able to compare two present figures, the present cost of investment and the present cash inflows, so that now you can be at fact. You know, a project might be seen to be profitable, but in the real sense, it is not profitable because of the time value of money. So that is what these techniques argue. So a good investment, we need to consider the time value of money. And actually, that is one of the characteristics of a good project investment technique. It should be considered the time value of money. So under these techniques, we have number one, net present value. NPV. Number two, we have profitability. Index, we call it PI. Number three, we have the internal rate of return, IRR. And then number four, we can also talk about discounted payback period. Those four techniques, they consider time value of money. So the ordinary payback period, we don't consider the time value of money, but the discounted cash flow or the discounted payback period, we can consider that. So we start with what we call the NPV, the net present value. This is it is like the backbone of all the others. If you understand the NPV, the others is going to be a small adjustment here and there, but it is the main one. The others, very easy. If NPV is understood. So under the net present value, or how do we get the NPV? NPV is equal to the present value. That means the one total. Total present value of cash inflows minus the cost of investment. IO. The total present values of cash inflow minus the cost of investment. Minus the cost of investment. I want you to have a look. It is very common, you know. I think even the last sitting it was tested. So let's listen. I know we have done the present value. It is very easy for you to do it. What we do for one project. That is discounted payback period. And to be for one project. Okay. So what we have here is for two or more projects. So let us do one of them. Let us start with the first one that we shall meet. Let us do question 4. About Rika intends to invest 2.5 million. Then the 2.5 is what we call the cost of investment or the cash outlay in either project PAMA or project NAMA. The expected cash inflows from the projects are as follows. So we have the inflows from PAMA and the inflows from NAMA. And you are told now you compute the NPV at a cost of capital of 10% for each project, and you advise the management on the project to invest in. So it is simple. Let us go to the board. We start with the project number. Sorry. That is those are the figures. So we need to get now, we need to get the present value interest factor. The rate here is what? Cost of capital is 10% for period end. And that one will assist us to get now the present values. I hope you remember how we get the present value interest factor, both using the calculator and using the table. So if you are using the table, the calculator, you will do 1, this is for year 1, 1 over, it is normally 1, yes, 1 over 1 plus r percent power n. That is how we get this factor. So 1 over 1 plus r power n, where r is 10%. So this one will give us 1 over 1 plus 10%. 1 plus 10%, you will agree with me, is going to be 1.1. So this is 1.1 raised to power 1, because it is for year 1. This is going to be 1 over 1.1 raised to power 2, because it is for year 2. This is going to be 1 over 1.1 raised to power 3, because it is amount to be received after year 3 years. 1 over 1.1 raised to power 4. Get your present value interest factors. You round them off to 4 decimal places. So for the first one, is 1 divided by 1.1, get 0.9091. The other one is 1 divided by 1.1 squared, 0.264. The other one is 1 divided by 1.1 cubed, get 0.7513. The other one is 1 divided by 1.1 raised to power 4, 0.68. Those are the factors. How do you get the present values? It is the inflow amount times the factor. So like for the first is 1,200,000 times 0.9091. You get 1,090,920. For the second is 800,000, the factor is 0.82 times 0.8264. You get 661,120. For the third year, 750,000 times 0.7513. 563,475. 600,000 times 0.6830. 409,800. Then you add the present values. You get the total present value of cash inflow. So you add them. Let me add going upwards. That's 2 millions.
725, 315.
315. Once you have obtained your total present values, you can comfortably get your NPV. It is the total present value of cash inflows, which is this figure we have obtained here, 2,725,315, you minus the cost of investment. This project, if it was to be invested, it would cost 2,500,000. 2,500,000. So we get is going to be 225. That is the NPV. That is the NPV for project Tama.
Excuse,
Yes,
can you move the camera so that we can see the part of umeandika NPV is cost to total present value of cash flows minus initial or cost of investment.
or
Thank you.
outlay. Cost of investment is the same as the initial cash outlay, IO. As simple as that. I want us also to calculate for project Nama. Have the year 1, 2, 3, 4, and 5. Then here we have the inflow. Cash inflow. Then we shall get the present value interest factor of 10% to the end. Then we get the present value. The inflow amount is 800,000. 800,000. 800,000 in year 3. 750,000. Then in year 5, you can have a scrap value amount. The value at the end of the project is 50,000, which you can receive. Then you get the factors for 10%. The factors do not change. The factors do not change. They remain to be 0.9091. As long as you are using 10%. These ones, they were also for 10%, so they will not change. 0.8264, 0.7513, 0.6800. Then we calculate for year 5. 1 divided by 1.1 raised to power 5. We get 0.6209. Once we are there, simple. Amount times the inflow, you get the present value. So you can get now the total present values and adding them. 2,532,725. So what is the NPV for project NAMA? Sorry. NPV equals to the total present values, 2,532,725 minus the cost of investment, which remains to be 2.5. So that is going to be that 2,725. That is how we get to the NPV. And as I said, if you are able to compute the NPV, then the others is going to be very easy. Very easy. So we need then also to understand how do we evaluate the project using NPV? What is the acceptance or rejection criteria? So under NPV, if a project with a positive NPV, it is considered to be viable. Any project with a positive NPV, it is viable or profitable, and it should be invested in. But in case we have the two projects having positive NPV, like in our case here, both of them are having positive NPV. This one 32.25 to 15, which is positive. This one has a positive of that 2,725. If both of them are positive, and the organization does not have enough capital to invest in both of them, you choose the one with higher NPV. You choose the one with higher NPV. But note, the bottom line, any project with positive NPV, it is profitable. Any project with positive NPV, meaning that the total present value is more than the cost of investment. Remember my argument was, or the argument of this discounting cash flow technique, we say we need to have the cost, because you are investing right now, but the benefits will be coming in future. Those benefits that will be coming in the future, we discount them so that we can get to the equivalent value right now at present. Then we compare the benefits at present versus the cost at present, because the cost will be incurred now. So we also convert the benefits which will be coming in the future into now, into present. That's what we call present value. Yeah? So once we have them at present versus the cost at present, we can be able to make the decision. So the benefits at present was 2,725,315 for project PAMA. Whereas the cost at present, if you are to invest right now, the cost is 2,500,000. So you can be able to see that the present value of the benefits is higher than the present value of the investment. So the project is profitable. But if you find the present value of the benefits or cash inflows is less than the cost, then that project is going to create a loss, or we are going to incur a loss in case we invest in that project, and therefore we reject the project. So in this case, PAMA and NAMA are both profitable, yes. But the organization or the management does not have enough capital to invest in both of them. So what do? The one with higher NPV is more profitable. We advise the management to consider it. So PAMA is more profitable. So because I think that was the second part of the question, advise the management. They should invest in PAMA because it has a higher NPV. But if both of them are negative, and you are told you advise the management, you advise them not to invest in any. So don't consider the one with a lower negative. No, it is not a must to invest in a project. If the projects, both of them are not viable, you advise them not to invest in any, so they should consider other projects. So that is it for NPV. That is it for NPV. So the others, I will just use these two examples to illustrate. Apart from IRR. which is a bit different, but for PI, profitability index, and discounted payback period, we can use the same project. So let me start with the profitability index. Profitability index, which is number 2, or PI, is calculated as follows. PI is equal to the total present value of cash inflows divided by the cost of the cash outflow. That's that. The process of getting the total present value is exactly the same. So, like for example, this project, PAMA, the present value, the total present value remains this. The same procedure. You get the present value per factor, you multiply by the amount or the inflow amount, you get the PV, then you add all the present values. You get the total present value of cash inflows to divide. So in simple terms, the PI, instead of subtracting, we shall be dividing these figures. So if you were to get the PI, it would have been 2,725,315. The total present value of cash inflows will divide by 2,500,000. That's that. The NPV we subtract. For PI, we divide. That's that. So in this case, you realize that one will give us 27, 25, 315. You divide by 2,500,000. You get 1.09. For this one, PI would have been, you take 2,532,725, you divide by 2,500,000. So your PI is 1.01. The PI is 1.01. That's that. The procedure is the same. That's why I said if you understand how to get to the NPV, the others is like that. Any question for those two approaches? The NPV and the profitability index. Janet? Oh, that is how we do it. Unless somebody has a question. So, for the discounted payback period, I only use this one for PAMA. The procedure is the same as the ordinary payback period, only that instead of using the cash inflows the way they are, we use the discounted. This is what the present value is, what we call the discounted. These are what we refer as the discounted cash flow. The discounted cash flows are the same as the present value. The discounted cash flows are the same as the present value. So in simple terms, instead of using the initial or the ordinary cash inflows the way they are presented in the question, we first of all discount them, and then we calculate the payback period using the discounted values. So we shall first of all discount the values, and then now we get the accumulated as we did. So you tell me the one you have recovered 1 kilo, 90, 920, 1 0 90, 120, you add 661, 120, you get 1,751,40 plus this 563, 475, you get 311, 314, 715 plus this 409, 800. 740, 740. So you don't need to get to the total when you are doing the discounted payback period. So you discount the cash flows first. And then now, remember, we want to recover our 2.5. This project was to cost 2,500,000. So the question is, how long will it take for us to recover the 2.5 million? We shall take up to year 4 or year 3. So the payback period will be 3 full years. Up to year 3, we have recovered 2,314,750. But we are supposed to cover 2,500,000. So what is the balance? You take 2,500,000. You minus what you have recovered, 2,314,750. We have a balance of 185,000. 285, which will be recovered from, where will we recover this from? We shall recover from the next year. 409. That is 3 plus 0.45. 0.45. Yes. That is the discounted payback period. The discounted payback period. That is the plan. So instead of using the ordinary cash inflows as they were given in the question, you first of all discount, and then you calculate the payback period using the discounted figures. But the procedure is the same as the payback period. That is the only difference. The ordinary payback period, we use the figures the way they are. The discounted, we first of all discount the figures, and then we use the discounted figure. So that is it. I want us to look at the last method, which is the internal rate of return, and that will be the end of the topic, capital budgeting. Internal rate of return, IRR. Internal rate of return, IRR. I'll give you the formula first. IRR equals to lower discounting rate, add NPV NPV at higher discounting rate. Then we multiply by higher discounting rate minus lower discounting rate. IRR. So HDR is the higher discounting rate. RDR, the lower So for you to be able to calculate IRR, you must have two rates. Anyway, before we even calculate, understand that IRR, it is the discounting rate that will make NPV to be zero. The discounting rate that will make NPV to be equal to zero. So at IRR, NPV equals to zero. It is a discounting rate. Remember, we normally discount these values using a certain interest rate. Like in the case of the example that we have just done, we were using 10%. That is the rate of return or the cost of capital. So at IRR, if you use the internal rate of return, that rate in percentage, and then we discount the amount, you'll find that the NPV will be zero. The NPV will be zero simply because the cost of investment will be the same as the present values of our cash inflows. So it is a rate that will make the present value of cash inflows to be exactly the same as the cost of investment. So that's why we are saying this. To calculate that rate, IRR, you take the lower discounting rate. So you are going to calculate NPV. For example, if you take the lower discounting rate to be 8%, so we calculate NPV at 8%. Then we also have a higher rate. Maybe, for example, you have 18%. So 18% becomes our HDR, higher discounting rate. So we calculate again the NPV at a higher discounting rate. For you to be able to calculate IRR, the lower discounting rate should give you a positive NPV, and the higher discounting rate should give you a negative NPV. And then the IRR, because it is going to give you NPV to be zero, the lower discounting rate is giving you a positive NPV. The higher discounting rate is giving you a negative NPV. IRR is in between them. IRR is between the lower and the higher. So we compute that rate using that formula. So I want you to have a look at a question that is this document. I think it is the last question. Okay. Yes, question 17. Magnet Ventures has borrowed 20 million from a bank at an interest rate of 14% per annum, which it intends to invest in a project. The following are the expected cash inflows from the project. So we are given the year and expected cash inflows, and then you are told calculate NPV at 14% and at 2%. Using results in Roman 1 above, determine the IRR of the project. So you can be able to see we have a lower discounting rate, which is 14%, and a higher discounting rate, which is 32%. So we are supposed to calculate the NPVs using those rates. So you can refer from your other gadget. I do it. I want us to finish this topic today. So let us start with 14%. So we have the year, the intro, the present value interest factor of 14% for figure N. Then we get the PV. Year 1, up to year 5. Year 1 to year 5. Year 1, the intro is 5 million. Year 2, 8 million. Year 3, 12 million. Year 4, 6 million. Year 5, 4 million. The present value interest factors. If you are given the table where and good, take them from there. But if you are not given the table, this is 14%. Never forget the factors are obtained by 1 into 1 plus r power n. So in this case, it will be 1 over 1 plus 14% power n, where n is going to be this years. So this one will give us 1 over 1.14 raised to power n. So this is how we do it. For year 1, it's going to be 1 over 1.14 power 1. 1 divided by 1.14, we get 0.8772. 1 divided by 1.14 squared. 0.7695. 1 divided by 1.14 cubed. 0.67450. 1 divided by 1.14 raised to power 4. 0.5921. 1 divided by 1.14 raised to power 5. 0.5194. Multiply the amount and the factor, you get the PV. This one gives me 4,386,000. 8 million times 0.7695 gives you 6,156,000. The other one is 12 million times 0.6750. 8,100,000. 6 million times 0.5921. 3 million 552,600. The other one is 4 million times 0.5194. 2,077,600. So you get the total present values because we need to calculate NPV at 14%. We add 3,552,600 plus 8,100,000 plus 6,156,000 plus 4,386,000. We get giving you 24,072,200. That is the total present value. So the NPV for this project at 14% will be total cash interest 24,272,200 minus the initial cash outlay. How much are we intending to invest in this project? We want to borrow and invest 20 million. So the NPV will be 4,272,200. That is the NPV at 14%. So you get the factors using 14%, then you get the total present values at that rate, you get the NPV at 14%. And remember, 14% is the lower discounting rate. So 14% is the lower. Then we go and get, using that 2%, you get 2 NPVs. So we do the same process here: 1, 2, 3, 4, and 5. The inflow amount does not change. 5 million, 8 million, 12 million, 6 million, and 4 million. Present value interest factor of that 2% is your N, and then we shall get the present values. So the same we shall do now: 1 over 1.32 our N. 1 over 1 plus R. Our R is that 2. So it will give you 1 over 1.32 power N, where N here we raise by 1, here we raise by 2, as we go down. 1 divided by 1.32, our 1 is going to be 0.7576. 1 divided by 1.32 square, 0.5739. 1 divided by 1.32 power 3, 0.4348. 1 divided by 1.32 power 4, 0.3294. 1 divided by 1.32 power 5, 0.2495. We get the present values at that 2%. $5 million times 0.7576. 3 million 788,000. 8 million times 0.5739. 4 million 591,200. 12 million times 0.4348. 5 million 217,600. 6 million 1,976,400. Last 4 million times 0.2495. You get 998,000. So how much is the total PV? Let me add going upwards: plus 19, 76, 400, plus 52, 70, 600, plus 45, 91, 200, plus 37, 88, get 16 million 571. Those are the total PVs. Then from there, you calculate your NPV at that 2%. NPV at that 2% is going to be 16,571,200 minus 20 million. That is going to be negative 428,800. And that's why I was telling you, at higher discounting rate, the NPV should be negative. At the lower discounting rate, the NPV should be positive. Then we subject the figures into this formula, we get the IRR. So the NPV at higher discounting rate is here. The NPV at lower discounting rate is here. And we have the higher discounting rate, the lower discounting rate. It is just a matter of now feeding the figures in the formula. So let me calculate it here. IRR will be equal to the lower discounting rate. We normally start from there. The lower discounting rate, in this case, we have it as 14%. Plus NPV at lower discounting rate was 42,200 divided by NPV at lower discounting rate again, 42,200 minus NPV at higher discounting rate, which we got here to be negative, 34,28,800. Then everything here we shall multiply by that 2% minus 14%. That's 2% minus 14%. That's 2. The higher discounting rate minus the lower discounting rate. Higher discounting rate is 32, lower discounting rate is 14. So what will be our final answer? 14% plus. This negative and negative will make this one to be positive always. It is minus, but this, because the NPV at higher discounting rate will be giving you negative. And here we have minus. That negative and this minus make it to be positive always. So we shall add this plus this. Let me do this part first. 42,200 plus 34,800. You get a figure there. Then I want to divide this, divided by the answer that I have obtained. 42,200 divided by answer, I'm getting 0.5548. Then I multiply by that's 2 minus 14, which is 18. So this one will be 14%. Work out that part first. Work out that part first. Multiply by 0.55 for 8. You get 9.99%. You get IRR equal to 23.99%. Almost 24%. That is how you get IRR. It is a procedure, but the procedure is not complicated. It is simple. Getting two NPVs, one using a lower discounting rate, the other one using a higher discounting rate. You need to be careful when you are using the higher discounting rate. If you are not given the two rates, in this question it was friendly. You are specifically told to use 14 and 32. Sometimes you cannot be told. You are told just calculate IRR. So you need to assume your two rates, but the answer will be the same. If you take, for example, 10% as your lower rate, calculate it. Then once it gives you positive, when you are choosing a higher rate, don't go to just 12% and you use 10 as your lower, and now your higher is 12. Go to the highest. If you are given the table, use the highest, even if it is 32 or 40%. So that you avoid. Remember, you cannot get IRR if the two NPVs are positive or if the two NPVs are negative. One of them must be positive and the other one must be negative. So if the lower has given you the positive, pick the highest so that you avoid the risk of getting another positive, then you try another higher. It will consume a lot of your time. If you have calculated the lower discounting rate, that is the NPV, when you are choosing the higher, choose the highest, and then it is going to be easy. So once you have the NPV at lower rate, usually or always positive, the higher discounting rate should give you negative NPV. Then you subject your solutions or your NPVs to this formula and say that your IRR should be equal to lower discounting rate plus NPV at your lower discounting rate divided by NPV at lower discounting rate minus. This minus the NPV at higher discounting rate will also be negative. This negative and this negative will give you the positive as we have done there. And then you multiply by higher discounting rate minus the lower discounting rate, giving that. Meaning that if you are to get NPV using 23.99% or 24%, our NPV will be 0. NPV at IRR is normally 0. So what is the question asking, part 2? Using the results in 1 and 2 above. Sorry, I think I'm in the wrong. Yes, using the results in Roman 1 above, determine the internal rate. We have done that. Advise the management on whether to invest in the project or not. When you want to advise the management using IRR, you compare the IRR that you have computed and the cost of capital. These 20 millions were borrowed. They were borrowed from the bank that charges an interest rate of 14%. So the rate or the cost of capital is 14%, the rate at which we borrowed the funds. But now the returns, internal rate of return, these are returns. We are getting returns of 23.99%. So the returns are higher than the cost. So we invest in the project because we are borrowing at an interest rate of 14%. But the project in which we are investing the funds will be giving us a return of 24%. The returns are higher than the cost. So we invest in the project. That is it. Any question as we wind up the class? So that marks the end of the topic, cost of capital. I want you to go to June 2023, the last series this year. They ask a question on NPV, you do that question, as you also work out on the remaining questions in that document of the time value of money class questions. So we shall meet on Sunday, we do the cost of capital. So with that, I wish you a very blessed day. Bye.
Bye, Mwalimu.
Bye, Mwalimu. Thank you for the class.